Hello everyone, my name is Mayron and welcome back to episode 3. Now first I want to point out that when I was trying to squeeze everything into episode 2 in multiple parts, I realised that that wasn't a very good approach. So incidentally, this has resulted in me having to restructure most of the series. So sorry when I said about episode 3 was going to be about scripts, episode 4 was going to be about this and that, because that's really trapping myself into a corner and it wasn't a very good idea to do that. So moving right along. This episode is going to be completely about tables and it might go into 2 parts. Let's just see how things go. So a table is a data structure which can store elements to be used at any time. So you can think of it as a variable which can store more than one element. Tables are divided into 2 parts. You have the array side of things, meaning that they're sort of indexed. So in other languages, like C++ and Java, an array is a list of elements that are indexed. So you can get to their locations easily. So the first element in an array, such as this 5 in this options array that I've created, or this options table I should be saying, is at position 1. In other languages, you actually start off at position 0. So the first element in an array in a different language would be at location 0, then 1. So the second element would be at position 1. The third element at position 2. However, Lua handles this much easier. The first element is at location 1, there is no element at location 0, it's actually just never used. So all elements start at location 1 and then you can transverse through the array by selecting different elements at different indexes in the array. So a good example of this is that if you want to select an element from a table in Lua, you'd have to do something like this. We have to declare a variable, local n, equals options and then use the square brackets with the index number of the location to which you want to grab the elements from. So in this case, options in square brackets with 2 would select the second element, and in this case the second element is number 4. So this means that local n is going to be assigned the value 4. If you select an element from a table with a length which it is greater than what it actually is, then you're not going to get a Lua error, you're just going to get a nil value. So if I were to try and select the 10th element in the options table, I'm just going to get nil because there is no element at location 10. So let's just try this out. I'm going to attempt to print the value of n, which should be nil. Okay, so yes, I got a nil value and I did not get a Lua error, so it's very safe to do something like this. Just another reason why Lua is a flexible language. It's also not dangerous to do something like this. In other languages like C++, it's actually possible to overload an array, meaning that you can select elements that don't exist in the array, but it's just going to select other elements from the memory storage area, and it's just going to corrupt the data. Nothing like that can happen in Lua. So this is the most simplest way to use a table, by treating it as an array. The other part of the table is known as the hash table, also known as the associative array, meaning that you can assign a value, a key, rather than an index. A key is basically just a string which you can use to identify an element in the array at a location, rather than relying on the index method. So for instance, maybe an option in this options table could be the size attribute, and you can have the key specified with a string called size, and it links to a value, rather than having to remember that the size element is actually at location, 50 or something. Now there's 2 ways of placing elements inside of a table. You can either initialize it, the table to have an element, or you can just shove it in at a later date. So you have to think of a table as 2 halves. You have the array part of it, and then you have the hash table. And this might sound a bit confusing having 2 data structures inside of just one data structure, but that's just how it works. You can initialize a table with its own values, its default values, but you can shove new values into the table at a later date. So in this example here, you've assigned the value 5 at location 10. And you might be thinking, well, this is a bit confusing because why are you shoving a value at location 10 when there's only 5 elements inside of this table? This just means that you're going to assign 5 to location 10, and anything from position 6 to position 9 will automatically be given the nil value. If we was using a key, however, you would do something like this. So in this case, we've given this value 10 the key called size. This means that if you try to traverse a table, meaning to go through the table using its index numbers, you'd never find this size attribute in the array part of the table. That's because it's actually stored in the hash table. We're going to be talking how to go through a table using a for loop, either by going through the indexes and selecting elements in the array side of things, or how to select the key and value pairs inside of the hash table inside of the table. However, if you wanted to turn all of these elements into a hash table and not even bother using the array side of things, you can initialize them to have elements like this. So here's an example of how you'd set up a table with default values using keys instead. And I haven't just included basic construction of a table. I'm trying to show you a more realistic approach using different ways of setting it up. So this is assigned the size key to 10. Maybe you might have an X and Y offset and give them some numbers as well. You can also assign a key another subtable like we've seen earlier. So in this example, you have the color key, and it's assigned a table with the R, G, B, and A values. And you've also got a class just here, and you've assigned it warrior, which is terribly spelt. Let me just correct that. And on purpose, I wanted to show you the difference between creating a key like this using a string, or you can actually make the key an actual variable. So in this case here, you'd have the class variable, and you'd assign it warrior. And this is actually a variable, not a string. But it works in exactly the same way, and when you're using the for loop to go through the hash table side of things, it's going to treat the class as an actual string, but it basically does the exact same thing. So in this case, you can have R, G, B, and A as variables, which select a different, color value. Now it's very important to remember, because this is a very typical beginner's mistake, but if you're having a table lined up in this sort of fashion with the curly brackets here and here, you might be forgetting that you're adding keys and values in a table, so you might forget to include this ending comma just here. Because remember, to separate elements from a table, you have to use a comma. So if you forget the comma, unless it's the last element in the table, so typically, you don't actually need a comma just here for the very last element, but I always encourage you to do so just so you don't make this mistake. But yeah, if you miss one out, it's going to cause a Lura error. So in this case here, if you wanted to print out the size element from the options table, you'd write this. This here would print out 10. However, if you wanted to print out the class of the options table, you can't use the same sort of fashion, and instead you would use the dot operator. It's not much of an operator, it's mainly just used as the memory location like other languages. So you'd think of this options as like a class in other languages, and this, the actual class of the class, it's not a very good example, but you know what I mean. It's selecting the class attribute of the class, but in this case it's actually a table. Because in Lura, you're using tables like classes from other languages, like an object-oriented sort of approach. But anyway, let's get back to the subject. This would print out 10, and this would print out warrior. So let's try this out. Alright, so there we go. 10 and warrior. And like things I've mentioned in the past, this number 10, that could actually be something that's going to be figured out later on. So, you could have some sort of find out the player's level. So in this case, you could have something like unit level, then player, to get the player level, and instead of calling it size, let's call it level, and then you'd print out whichever level my character was, and then in this case it would be level 1. So yeah, look, level 1 warrior. Now what you should remember is that getting the length of a table only gets the length of the array side of it. It only takes into consideration the indexes. So if your table has no index section and instead just has keys and value pairs, then that doesn't actually count towards the length of the table. So you should just think of this hash operator as actually just getting the length of the array part. So if I were to do this, it's going to print out 0 because we don't have an array part. It's only key and value pairs. As you can see here, the 1 is from the options level, which we've already discussed about, and it prints out 0 as the length of the table, so yep, that makes complete sense. If I were to do something like this, however, 1, 2, 3 and 4, without giving it a key, it's going to add that to the array side, and it's going to print out 4. So yep, now it's printed out 4, that's exactly what we want. Now, if you're going to create a sort of object using a table, you need to give it some methods, or functions in this case. So it's kind of logical to assume that keys can actually be assigned functions as their values. And yep, you can definitely do that. You can have any data type as the value inside of a table. You can have characters, and you can even have subtables, so why not functions? It just makes sense. So let's make a few functions. Now I have just created two functions for the purpose of this example, which basically just use an abstract data type called a stack, which I'm going to explain just in a bit, in order to move around data. Now I have decided to go with a variable name to be used as the key for that function in order to access that function, in preference to the other method of using a string as a key. Now the difference is that if you use a variable name, it looks a lot nicer because it looks like you're using a function as a method to be applied onto the object, which is the table, which is the same sort of style that Blizzard uses for their widgets. Now widgets are basically just tables, and like I've mentioned before, a widget can be like a frame or a button, and each one of these widgets have their own set of methods, and a method basically just means a function which is dependent upon an object. So if a function is exclusively only used for that object, then yes, you can call it a method, but in Lua it's basically just called a function, and the two terms sort of get mixed up and confused around the world. This is because in most languages, each language has their own different way of handling their own interpretations of what they're talking about. In languages such as C and C++, I'm pretty sure they just call them functions, and in Java usually it's just called methods, because it's a function being applied to an object, and they like to be special. And you can basically just call it what you want, it doesn't actually matter. So sometimes you might hear me getting muddled up with methods and functions, but my point is that functions and methods basically are exactly the same thing, it's just a term. So I highly recommend using variable names rather than strings as keys for functions. It doesn't matter if you want to use strings as keys for any other data type, but for functions, try and stick with using variable names because it sort of depicts it as a method. And it's just a nicer way to lay it out, and it's going to make programming a lot easier in future. So now you might be asking, well, what do these functions actually do? Well, let's first explain what a stack is. So these two functions here are basic functions used when working with stacks. Now a stack we're not going to talk about too much, but you can think of it as an abstract data type where you can use an array as a stack, meaning that you can pretend it's like a stack of books. You put one book on top, that's pushing an element into the array, or the stack in this case, and when you want to pop an element, you pick up the top element from the stack, and you can do whatever you want with the book, use it in the rest of the program, whatever, doesn't really matter. But yeah, the general idea is just putting elements on top and taking them from the top. There's another abstract data type referred to as a queue, which basically just does the opposite. So you put elements on top, and then you take elements from the back. But these two functions are the general concept of how to create such a thing. But anyway, enough of that. Let's go back and start talking about how functions can work inside of tables as the values. So these two functions here can do pretty much anything a regular function can do outside of a table. It can receive arguments as inputs, and it can also return values as outputs. So in this example here, you've got push. Push takes one argument, well technically two, but we'll talk about the use of the self argument later on. So you supply it with one argument, and then this argument gets added to the array side of the table using the indexes, not anything to do with keys, just the indexes. So in order to find out the next free spot in the array, you have to find the length and then get the length of the array and add 1 to it, so then it adds something to the next position in the array. So remember that the length operator just here will get the length of the table. The self argument is thought of as a self-referential argument, meaning that it selects itself, and in this case we want the self to be the options table. So pretend that self is the options table. So the options table is going to get the length, and it's going to supply the outcome to the variable n. So self square brackets n+1 means it's targeting the next free space, the next index position that hasn't been used yet, and given it the arguments that we've supplied the function. Now the pop function basically does the opposite, however it does two things. It returns to the function call, wherever it was called in the program, it returns the value at the end of the array part of the table. So if the array part of, was 50 in length, it had 50 elements, each organized at index 1 to 50, then it's going to give you the value at position 50 by using its index, and then it's going to remove the value at position 50 in the table from the table by assigning it the value nil. The array part of the table, it can have an element at position 1 and an element at position 50, and it could even have elements from 2 to 49 all as nil values, but it's still going to return the length of the table as 50. If you have a load of elements after 50 which are all nil, maybe it's 1 to 60 and after 50 it becomes nil, then when you use the length operator, the hash sign, it's actually just going to return 50 because it ignores anything after the last significant value in the table. So in this case, n equals 0 because the length of the array part of the options table doesn't actually have any values yet. If we supplied it something like this, then that means 1 to 5 here is going to be stored in the index part of the table, the array part. So just keeping them there for now, 1 to 5. This n is then going to become 5 because that's the length of the table. And then it's saying if n is greater than 0, in which case this is, it's going to grab the value at position n, which in this case is position 5. So it's going to grab 5 because element at position 5 is also called 5, which is a bit annoying, but RTN, the return value, is going to equal 5, and then it's going to return position 5 to nil, so it's basically going to make the size of the table a lot shorter by 1 point, and then it's going to return the value that we've just grabbed. Hopefully this is easy for you to understand, but these 5 values that we included in the array part of the table, I only added them there as an example, and by default, in the real world, these wouldn't really be here, so let's just delete them for now. And that means that the length operator will now result in 0 when you first try to run the code for the first time. So that's why we have to +1 because you can't assign anything at position 0. So the next available one would be 1 in this case, and just here you can't pop anything because there's nothing to be popped, there's no value. So yeah, that's why you have to use that if statement. So I've created some test examples just here, but I have to sort of explain what's actually happening because it might be a bit confusing, but I've had to supply itself to be transferred to the self argument in the functions. This is because when you have functions inside of a table, you can't refer to the table itself because the table hasn't actually been set up properly yet, and it's just because of how Lua works with its lexical scoping. You have to have a variable name that refers to itself, a self-referential variable. So this looks a bit horrible, but there is actually a nicer way to do this. Because the people who made Lua know that this looks a bit messy and this is a problem, they've created a very nice way of actually dealing with this self-referential functions inside of a table. It's very common to have tables that have functions and to treat a table as an object and have functions act upon that table. So you can actually turn this point, this memory location sort of operator, this dot, into a colon, like this. So because Lua runs from left to right, it's going to see this first, the options variable name, and it's going to realize that's a table, and then it's going to see this colon. And now colons are only supposed to be used with function calls. So because of this, it's going to say, oh okay, so the right hand side of this operator is actually going to be a function call. So before it even gets to the parentheses, it's going to note down that this next thing is a function, and it's automatically going to generate a self-referential variable to go inside of the parameter, which is completely invisible to the user. So this options variable name is automatically going to be supplied. So you can actually just do this now. So options colon pop is basically going to fill in the self-referential variable automatically, which is just, it sounds a bit strange, but this is just to make programming a bit easier. I wouldn't really think too much into this, but this can also be a bit confusing, because some people accidentally don't fill in the self-referential variable and sort of, for this push function, completely forget to put it into the signature. So the self-referential variable is going to become arg, so arg would become options, and that's going to corrupt the entire code and it won't understand what self means. So if you're going to use this method, always supply self at the very start of the function parameter list. This is why event handlers in code that you see on wowprogramming.com always have self at the very start like this. It's not there for no reason. You just have to remember that functions inside of a table cannot reference the table itself unless you supply the self-referential variable. Just because of programming conventions, we always call it self. You could actually call this whatever you like. Java tends to use this, the keyword this, and so does I think C++, but in Lua we always just call it self. So now that I've explained what this means, you can actually go ahead and remove all of these options keywords and change this dot memory address operator into a colon. Okay, so now this looks much neater. So now I'm going to explain line by line of what we've actually done. The first attempt is to pop the first element in the index part of the table. We've removed 1 to 5 now. This does not have any index part of this table by default, so the length of this options table will be 0, so the if statement makes sure that you can't pop anything. You could have always returned an error message or a nil value in case n is less than or equal to 0, but we're just going to keep it simple and not return anything, meaning that nothing gets printed. If you had a variable to catch it, then that would have gained the nil value, but because we're trying to print something, it's just going to print nothing at all. So next we're going to push 50, and then we're going to push 4, so 50 becomes located at position 1, then 4 is going to be located at position 2, 100 is going to be located at index 3 or position 3, and so forth. Because now we have pushed 5 elements into the stack, it's now going to try popping the 5 elements. And you have to remember that it goes from top to bottom, so the ones we added on last are the ones that are going to be popped first. So the first element to be popped will be the table, and then the string hello, then 100, then 4, then 50. Now you might think as a beginner that when the table gets popped and it goes to try to print the table, that it's going to try and print all the values inside of the table, maybe with its index numbers, but no, it doesn't do any of that. Instead, it just prints the memory address where the table is stored in Lua memory. So it's just going to print the reference, and usually the reference for a table would look something like that comment I have on the right side of it, as you can see just there. I've commented at the top just there that it's a nil value, but no, that shouldn't actually be printed, so instead it should print, as you can see just there, the table reference, hello, 100, 4 and 50. So let's run this code in World of Warcraft to see if it matches my prediction. So yeah, that looks exactly right. The only thing that I did mess up on was the table. Obviously the memory address looks a bit different, but no programmer is ever supposed to remember what that means. It's just only meant for the Lua interpreter to understand. So in the next episode, I'm going to have to remember to talk about for loops, because there are 2 Lua functions that can be used to go through an array part of a table and a hash part of the table to print out all the data stored inside of tables. Now this is a lot more fun than it sounds, because you can actually print tables that Blizzard have added into their user interface. So you can print all the data that represents certain graphical user interface elements in the UI. So for instance, you can print the character frame and it prints all of the different pieces of data that make the character frame, and it can actually be something really useful for when you're trying to reskin the Blizzard UI like I've done in the past. So until next time, please make sure to leave comments in the comments section if you need any help. I'll try and answer as much as I can, but maybe I'll end up just making a Q&A video or something. So this has been Mayron, and until next time, bye for now.